Thanks everyone. My name is Alpha. I am a staff engineer at Attentive, and today I'll be talking to you about Attentive's journey from Amazon Kinesis to Apache Pulsar. So we'll have like a few parts to this talk. First, I'll tell you a little bit about Attentive and how we came to build an event processing solution on top of Amazon Kinesis. And then we'll talk about the reasons why we had to migrate that solution to Pulsar. And finally, I'll tell you about the migration journey and the results of the migration process. So some history. If you've ever seen something like this when you're trying to shop on the internet, where you go to a brand's webpage and you land on the homepage, and you see like a prompt that says, "Hey, put your phone number here," and you get like a 10% off coupon or 20% off. Of course, everyone likes 10% off, so you put your number in the box. And if you ever run into such a system, it's very likely that Attentive is the back end running that system. So if you do that, what you get, maybe like a few minutes later, you'll get a text message from the brand that says, "Hey, customer, there's this new thing on our that we are selling. Click here and go to maybe purchase." We also have another source of flow that we call journeys, where let's say a customer puts something in their cart and they haven't bought it for, let's say, like a couple of days, right? A marketer can set up a system or a flow in the back end to basically target users like that. We call that an abandoned cart journey, and we have a lot of these. So it will basically text the customer and tell them, "Hey, you left something in your cart, go and continue your shopping, click this link, go back to your cart." So we have thousands of brands as clients, and we send millions of these messages a day along with millions more of emails, right? So it's a big business. It requires a lot of back-end functions, right? So if you think about it, you have to build a system, to send the messages, right? That's the messaging domain or the messaging team. But before you do that, you have to build a system to compose messages. So you need campaigns. Before you actually do that, you need to build a system to ingest and store users' information. So you need subscriptions, right? So while all these domains have like their own unique function, they're not isolated completely, right? They all need to collaborate, they all need to share data, right? So we need to make it possible for these domains to collaborate and share data. And how do we do that, right? So there's a lot of alternatives. A lot of us have learned not to do that, but you could have a giant database where all the services just query data and go fetch data in a single database, right? Probably don't do that. Another way would be you have like API calls where if you need data from another service, you go fetch that data using the API. That can take you far, but that also has downsides as well, right? What we have done at Attentive from the early days is to embrace an event-driven architecture, right? That gives us looser coupling and a bunch of other things that may be like outside the scope of this discussion or have already been mentioned. So the basics of the system look like this, where we decided to have a single stream that producer of any domain can just put data into that stream if they want to share a certain data out of their domain, right? So we have a single event stream we call the raw event stream, and everyone can put data into that stream that they want to expose to the outside of their domain. We call it the raw events because you can put an event into the stream, for example, that has a company ID that could be just a raw ID in a database, right? And then in front of that, we have an enricher service that can take that data, enrich that company ID information, for example, with the website or the actual name of the company, and then it can put that data into an enriched event stream that then everyone can use because the data is now enriched and it can be used as it is without having to go fetch more data again. So we have again, a single service that can just do all of that for everyone at the same time, right? So now that we have this enriched event stream, how do we share data? How do we then deliver this data from the enriched event stream to all the domains that need this data? So this is the problem that we were facing, right? We have a single enriched event stream. How do we get data everywhere? One way you could do that is you would say, all right, let's just have every service that needs this data just subscribe to the enriched Kinesis stream. Well, in theory, this is possible. In practice, it's really not possible with Kinesis, and there's a couple of reasons for this. One is Kinesis, the scaling unit of Kinesis is called a shard, and a shard gives you 2 megabytes per second of outbound traffic, or 2,000 records per second, whichever happens to be greater. So if you have one consumer, it gets 2 megabytes per second. If you have 4 consumers or 5, they all share that 2 megabytes per second. You could say, all right, let's just add more shards, you get more throughput. Sure, you could do that, but there's an even more challenging quota in Kinesis, which is you can only make 5 requests per second to fetch data. So if you add 200 shards, you can only make 5 requests per second to fetch data. So at the end of the day, if you have any real-time requirements, you can really only add, let's say even if your real time is like 1 second, you can only add up to like 5 consumers, right? So you're pretty stuck, regardless of how many shards you have. But another issue is that if you look at what we have here, if a consumer needs to get data out of the enriched event stream, and let's say there's 100 event types in this stream, and you have events of different priority and volume, right? A consumer has to read all of the data out of the stream to actually be able to, let's say, take one that he actually cares about, right? So it can be challenging where you have to deploy like a huge fleet for each consumer to basically read all the data in the stream, take out what he needs, and then do what he needs with the small amount of data that he needs. So what happened is that because this fan-out issue is so difficult, we ended up with a system like this where you have a complex system of using fire hoses and going to S3, and then fire hoses going to like Lambda, and then Lambda to SQS. It was just a complicated mess of things that were difficult to manage. And at the end of the day, we were still not able to overcome the 5 limit problem, because you can do this here, but you're stuck basically because you can't add more real-time consumers. You can fan out downstream, but every hop you add makes the data even slower and slower, right? So, if you're the CEO of a certain company, a certain car company, you might say we dug our own grave and we had to dig out, right? So that's what we try to do. And how do we do that? We created a new team called the Event Platform team, and we tasked this team to try to solve this fan-out problem that we have with Kinesis. So to recap what we want, we want to be able to fan out to more consumers, as many as we need, right? We want to also be able to do event replays, right? Why do we want to do that? It's because, well, accidents happen, right? A few common issues that we have all the time where a team would come and say, hey, we lost some events, or we miscomputed something, we have like a bug for like 2 weeks and we just found out. How do we replay all the data in the past to be able to like fix, recompute these events? So we want easy event replay. We also want these pipelines to be simple and flexible. We want all our data pipelines to be pluggable, extensible, easy to support, all that stuff. And we also want to maintain loose coupling between all the portions of the system, right? We don't want to make something that's going to basically lose the trade-off of being able to use streams. So with that said, the solution we came up with was, at the core, was a concept of a data stream. And a data stream is really just something with a source, right? A sink, and some kind of transformation, some optional transformation. So in this case, you see we have a data stream where an engineer can come and say, here's my data stream name, my source is the enriched events Kinesis stream, and my sink is my private Kinesis stream, and I want you to filter these events and only send me those into my stream. So if we can expose an interface like this to teams, how do we make that a reality? So we built a system that we codenamed Maestro for reasons. I'm going to talk away like the legacy pipelines that we have, the whole SQS and in the neat box there. We'll come back to that. So Maestro is composed of mainly 2 components. We have what we call a data stream registration service that is the interface between the teams or the engineers, the users, and the system. We also have Apache Flink as the core execution engine. And the data stream registration service can take this data stream definition that I showed earlier and map that to a Flink job, right? So it can take this source, map that to a Kinesis source, take the sync, map it to a Flink Kinesis sync, and you can take the filter, the event filters, map that to a Flink filter, and create a Flink job that's going to run and basically send the events to wherever they need. So this gives us a much simpler system, something that can be reused very easily, and it's very easy to create. All the users have to do is give us a data stream definition, and we map that to a Flink job and give them their events, right? So we solved a few of the problems we mentioned. We have like the simplicity of the system. We can send data to different places without people having to worry about, creating like and owning extra infrastructure. But how do we get around the 5 limit problem? We haven't solved that, right? There's still like, if you still want to read from, Flink still has to be a reader from the enriched stream. So how do we solve that? We solve that by using an offering from Kinesis called EFO, which stands for Enhanced Fanout, which they make you pay for, when we'll come back to that as well. So EFOs give you a dedicated 2 megabytes per second for each subscriber that you add, but there's also like a 20 cap limit to EFOs as well, right? So you can add up to 20 EFO subscriptions, and then you're done. You cannot fan out anymore. So what we do when we get to that case is we add just a replica. We use one of the subscriptions that we have in the limit, the 20 limit. We do a replica of the stream, and then we can fan out from there. So we technically can have infinite fan out. And what you see here that we also simplified, we also have every stream that we create, we can back it up to S3 as well, just using Flink as well. We also put the data warehouse and the ETL pipeline behind Flink. And this S3 event backup is actually done in Parquet, so it gives us, I guess, a free tier storage in a way, if you want to think about it. And we can use that for event replays as well, because we can just go to S3, say, replay events from this date to that date, and we have our replays as well. So, and just like that, all of our problems were solved. Like everyone had their own Kinesis stream. No one was like stepping on anybody, and people could just consume the data that they need, and only the data that they need. So we all celebrate, everyone's happy, and then, we see the Kinesis bill, right? So we started working on Maestro, I think in April of 2021, and by the end of the year, we were paying several thousands of dollars to Kinesis every month, just for Kinesis, right? So obviously, something had to change. This could not go on. We had to find a different solution. But cost wasn't the only problem, actually, with Kinesis, or at least for us. Another problem was using Flink and EFOs with Kinesis had I would even say a bigger problem in terms of stability. The Flink connector, or rather the Kinesis EFO subscription, does not respect back pressure. And if you're building an event-driven system that does not respect back pressure, you're in for a lot of pain, and we experience a lot of pain. So what would happen is if a Flink job gets behind for whatever reason, the EFO subscription would send that 2 megabytes per second constantly without respecting any back pressure. So what would happen is if a Flink job is not able to keep up, is that it gets into a constant failure loop, and you have to get an engineer, somebody gets paged, and people have to come and take manual action to fix it, right? So it was a big pain. We had to just find a different way of doing fan out. So that's why we decided to look for alternatives to Kinesis. And what were we looking for? Obviously, the basics. We wanted to be cost-effective, high throughput, at least once delivery, all that stuff, right? But we also wanted to be self-hosted. We wanted something we could manage ourselves. We wanted something we could host internally and run confidently, right? Not because managed solutions are bad, but since streaming and event processing is so important to our business, we wanted to remain in control of our own destiny. We also wanted something that integrates well with Flink, obviously because that's the core of our processing, event processing. And we thought, all right, since we're actually going to go through the trouble of changing our event processing solution, why not swing for the fences, right? So what if we could get something that could do more out of the box, right? So all right, let's look for something that can support multi-region deployments, because another issue with Kinesis is that you're stuck in one region, right? So even if you can replicate the data yourself manually, there's still the important step of having to replicate your consumer offsets, and which is not trivial, right? You have to build a solution for that, right? So having something that does multi-region is great. It has to obviously support back pressure because we lived through that and it's not great. Maybe if you can do streaming and queuing in the same system, that's also great. So we looked at all these requirements and we found that Pulsar is really the system that fit most of these needs or all of these needs, right? Compared to like other solutions, with, let's say like Kafka, obviously we looked at it. And starting in Q1 of 2022, we did a POC with Pulsar. We find that it works well with Flink. It works well in terms of like at least the cost that we projected it would do. The performance, all of that worked pretty well. So we decided to go with Apache Pulsar as our new system for event streaming. So because we wanted to self-host, we didn't want to do a migration like a big bang migration. We wanted to like do it slowly and gain confidence to know that, hey, we can actually run this thing in production under real load. So we wanted to find a system or a problem in the system where we can do a good trial, something that's like not like change everything at the same time, but at least it's actually worth doing, right? We don't want to do like something that's like too low-hanging fruit. So the first system we wanted to tackle was, if you look at the left side of our event-driven system, we have this enrich events, so this raw event stream, this raw event Kinesis stream, where every producer is sending data. So there's a bunch of problems here, obviously, right? One, everything is going to one stream, but there's a reason why we did that, because we don't want the data to be spread out all over the system. It's going to be difficult to actually find the data you need, right? And you take advantage of the enricher service. But let's say there's a backfill happening with some team. We have like a new customer being onboarded into the system, and you have to do a backfill of like 12 months or like 2 years of data, right? Those historical events don't have high priority, right? But once they're in the system, the enricher service has to treat them the same as any other event in the stream, right? So you can have like low priority events just overwhelm higher priority events. So we thought, all right, we can, let's see if Pulsar can help us handle this issue. And we thought being able to like, what we built was something like this, where we introduced a router in front of the raw events Kinesis stream. You split the events into 3 topics, and we can use the rate limiting capability of Pulsar to basically rate limit the lower priority and the medium priority, and just let the high priority events go through the system faster, right? So this gives us, all right, we can run Pulsar on the load, and we can also verify the capabilities of like of rate limiting, which we can't do that easily with Kinesis. You would have to build an extra system on top of Kinesis to be able to do rate limiting, right? So this gives us like a good demonstration of what Pulsar can do. Another urgency to this thing was that we had to do this very quickly before Black Friday, which is a big thing if you're in retail or online retail. So we got to do this pretty quickly. We got it to run under like very high load, and we were pretty convinced, all right, we can take Pulsar further. Let's make it official. We'll make Pulsar our system for event streaming. So, all right. Gonna skip those. So the second thing that we wanted to do was to reduce the usage of Kinesis EFO. One, it costs a lot, and two, like I said, it's very problematic when you're using that with Flink because you don't have back pressure, right? So what we did here is very simple. We just put a copy of the enriched events Kinesis stream into a Pulsar topic, and then we have Flink fan out from that Pulsar topic. So this gives us 2 things: the cost reduction of having to pay extra for the Kinesis EFO subscriptions, and we get the back pressure and more stability in the system. The next thing was to be able to migrate all those private Kinesis streams that we created for fanning out the data. So up until now, the Maestro team was the only one really using Pulsar, and now we're exposing Pulsar to the rest of the teams in the system, right? So this is the first time teams are getting exposed to Pulsar. Here, all we did is do a dual consumption model where we have the consumers connect to both a new Pulsar topic and stay connected to the existing Kinesis stream. And then since we control the producer in Maestro, we can just flip the producer to write to the Pulsar topic, and then we go back and delete the Kinesis stream. All this was made a little bit easier because we have an abstraction that our team owns. So the teams actually don't have to change any business code because you have an abstraction over all the streaming libraries that we use. We don't use like the Pulsar library or the Pulsar client directly in business apps, or the Kinesis SDK. We use a wrapper around us. It was a lot easier to make this change. The next phase was migrating streams that are not part of the Maestro ecosystem. So a lot of these streams are mostly within a single domain where we have a team that wants to do distributed messaging within their own domain, where they have like, a service and another service, and they want to just exchange data through a stream, but they're not necessarily having to go through Maestro, right? They don't need Flink or anything like that. So with those, we again follow the same model we did with the previous one, where we just do a dual consumption and we swap out the producer right into the Pulsar topic. But we mostly automated this stuff where we use our data stream registration service, and we can override both the producer's destination and the consumer source without the team having to really do anything. All they have to do to help us to get this done is to just do a redeployment. We can, automatically just migrate their stuff without them having to do much else, really. And phase 5 is getting rid of all those legacy pipelines that I mentioned in the first place. This is not done. This is where we are actually. Here, some of the challenges is because these are proprietary. A lot of them are proprietary AWS clients, so there's no like Kinesis equivalent, right? For example, there's no, as far as I know, there's no like great Lambda integration for Pulsar, right? For example, right? So, for example, for Lambda, what we do is just use the Pulsar client, the Pulsar Python client to replace the Lambdas. For Firehose, we use our S3 event backups, and and once that is done, we will just go back and delete all the legacy code and Kinesis streams, and that will be the last of Kinesis that we have in our system. So, time for some results. So, you can see here the actual limit of an account for Kinesis shards is 500. You see our limit right now is 20,000. That's because we have to tell AWS to really help us raise this limit over so many times, right? Because we're using so much Kinesis. And you can see where we're heading at October 2022. If we were still using Kinesis, we would have been over this limit as well, and we'll be paying a lot more money to Kinesis. So you can see our trajectory because we're not done. We're not, all cases not done, but a lot of it is gone. You can see our Kinesis bill. We were able to lock in the gains pretty early in the year of 2023. We did a lot of the work to get rid of the EFOs because they make up a lot of the cost. Like by far, they make up a lot of the cost. So our Kinesis bill is a lot better these days. You can see our usage of Pulsar has grown a lot. I think if I remember correctly, since January of this year, we've had a 450% growth, and ever since we went to Pulsar for the first phase of the migration, there's been a 950% growth rate in our incoming write rates into Pulsar. And our Pulsar cost has been pretty predictable, right? Not like the curve of like cost is not, scary. And overall, we've estimated about an 85% savings versus a comparable Kinesis workload, at least in our estimation. This is just a little snapshot of how we track the progress of the migration. Just to give you a sense of the scale, you can see there's a ton of like consumers and producers on both sides. Flink and EKS, it just means like services. But yeah, we were able to automate a lot of this because if you have like hundreds of workloads, hundreds of streams, and hundreds of producers and consumers, it's very easy to have like something fall through the cracks. So if you can automate a bunch of stuff, definitely go for that. And finally, challenges and lessons. So the biggest one I would say that we had was is a minor data leak where we lost about 1 out of every 200,000 events we lost due to a bug, I believe, in the Pulsar client, where if you had cumulative ACK enabled and ACK timeout enabled at the same time, you will lose data every now and then. So you have to send probably like about 1 billion events before you notice this leak for some reason. But we had a very solid validation plan, so I recommend you have a very solid validation plan. And that means you literally check every event that you put here has gotten over there. So, and that's how we found out. Fortunately, we were able to work with our partners at Stream Native to find the reason and get it fixed pretty quickly before we went to prod. The second challenge I would say is around observability. If you're using a streaming system, it's very likely that your teams and everyone is depending on dashboards and like alerts that are using the existing metrics from the old system, right? So if you migrate from Kafka, you're probably using Kafka metrics. If you're migrating from Kinesis, you're probably using Kinesis metrics. So being able to automate that is a challenge for sure. So definitely plan around being able to do that. The third one is no one likes doing migrations, right? If you have a cute little migration project, well, this other team, they have business requirements, right? They don't want to like stop what they're doing to help you do your migration. Even though we are convinced that Kinesis Pulsar is great for us, teams still have they have roadmaps, they have things to do. So being able to automate as much as you can, so you reduce the burden on teams, is definitely going to help you get done faster and actually have some correctness as well, right? You don't want to be doing too much manual stuff. And finally, it will take longer than you plan, so plan accordingly.